The very first section in geometry is on points, lines, and planes, chapter 1, section 1. And to start out, what does the word geometry even mean? Where does it come from? Well, geometry, if you break it up into two parts, you have geo, and if you think of other classes, or geography, geology, these are all studies of the Earth. Geo indicates that you're talking about our planet. And this metry. If you think of what word is close to that, you think metric, and metric is kind of our system, well, not our system of measurement, but the most common system of measurement used worldwide. So really, we are talking about measuring the Earth. Geometry literally means earth measure. In this first section, we're talking about points, lines, and planes. These are kind of the basic building blocks of geometry. We're going to talk about other basic geometric figures and some definitions. We start out with these three basic undefined terms, points, lines, and planes, and you might be questioning, why are they undefined terms? Aren't we going to define them in a sense right now? Well, they're undefined terms because they're sort of our starting point. We have to have these three general concepts as an idea that's sort of accepted by everyone. These are our starting points, points, lines, and planes, our basic building blocks, and then we can go from there and come up with a multitude of things beyond points, lines, and planes. So starting out, what is our common, basically, universal idea of a point? A point doesn't have a size, it's just a location. You indicate it with a dot, and by saying it doesn't have a size, whether I do this point that size and say that this is point P, or whether I make it larger, it's still point P, it's still in the same location. It doesn't really matter the size that I make this dot. It's just representing this spot. This point is point P. If you notice, I said we name it with a capital letter. Every point is named with a capital letter, and it's represented by this dot. Again, it doesn't have a size. The bigger I make the dot doesn't matter. It's still just a point. It's just a place. What is a line? A line has one dimension. It's a straight line and continuous. Arrangement of infinitely many points. Saying that it's continuous and an arrangement of infinitely many points, we do have to have an arrow on both sides of a line. Actually, doing a line like this kind of indicates it really is infinitely many points placed together, and then eventually you just create a solid line. But again, you do have to have arrows because a line goes on forever in both directions. I'll do another example of a line here. Again, straight and continuous. Continuous meaning put arrows at both ends. How do you name a line? You name with 2 points on the line or a single letter. So first I'll put 2 points on here, and this could be point L and point N. And then to actually name the line or represent it, we would say that this is line LN, and you literally put a mini line over the top of it with arrows to indicate that that's line LN. I could also use those 2 points and just change the order of them. This could be line NL, again with a line actually over the top. A lot of symbolism in geometry, a lot of symbols that stand for what we're representing. So this is saying I'm talking about this line NL or line LN. Also, you can use a single lowercase letter to name a line. So this could be, in the lowercase we do cursive. Lowercase cursive. And if I'm going to say this is line M, you do have to actually write the word line. I could also call this line M. So actually 3 different ways to name a line. With 2 points, you could switch the order of those points, and also with one lowercase, generally cursive letter. So we talked about points and lines. Now we talk about a plane, which a line was one-dimensional. A plane is 2 dimensions. We're thinking it has a width and a depth. It's a flat surface without end. So we imagine a flat surface going on forever. However, the way we draw this is generally like a parallelogram, trying to give it some depth and realize that it does have 2 dimensions here. But you have to continue this this plane going on forever. So you think of a flat surface going on forever like the floor that your desk is sitting on or you're sitting on. Imagine that floor going on forever in all directions, like continuing into other rooms or other classrooms. So it's a flat surface without end. The way that we name planes is either you pick 3 points on that plane. So I'm going to put 3 points on this plane. How about P and A and N? and then we write the word plane. So this is plane. I could do P-A-N. I could really do any assortment of those 3 letters or any 3 points that were on this plane. Plane, N-A-P, A-N-P, A-P-N, however you want to name those 3 letters. There's another way to name a plane. You can do one cursive capital letter. Remember that a line was lowercase. We can do one capital letter. Let's say, and generally cursive again, so I could say this is plane T. Again, cursive, but capital letters for planes. So we talk about plane being defined by 3 points, whereas a line was only 2 points. Again, plane is 2-dimensional, flat surface that goes on forever. So those were our 3 undefined terms, our 3 building blocks that start all of geometry. 2 more terms for you, collinear and coplanar. And if you notice this prefix co, if you think of like cooperate, means you're working together. Anytime you see co in front of something, it generally means that something is working together, or there's some sort of cooperation involved. Now, you know from last year, linear always means line, so co meaning together and linear meaning line. Something's together on a line. And generally we're talking about points being together on the same line. Again, co meaning together, and linear, of course, meaning line, so points on the same line. Coplanar, then, would be together on the same, well, planar, obviously kind of looks like plane, so this coplanar means points on the same plane. And quick review with these questions. Again, how many points do you need to actually draw a line? Or name a line, in a sense. If I wanted to actually draw one line right here on this page, how many points would I need to put? Well, if I only had 1 point, I could draw an infinite number of lines through that 1 point. But once you put a second point, now the only line that you can draw, well, I'll miss that point, sorry. The only line that you can draw through those 2 points is this one single line that would definitely intersect both. So how many points do you need to draw a line? You need 2. How many points do you need to draw a plane? Remember that we name a plane with 3 letters, 3 points, and you need 3 points to talk about one single plane going through. We'll talk about this a little bit more in class. But for any flat surface or any 3 points, there's only one flat surface that goes through them, or any flat surface you can name with 3 points. Alright, example using some of these naming techniques for points, lines, and planes. Give 2 other names for, now this is line BD. Give 2 other names for line BD. First, let's locate it down here. I see point B here, point D here, so this is line BD. Now remember that the simplest thing you can do is just change the order of how those points are written. So instead of BD, I'm going to do DB. Line DB, of course, so I put this symbol over the top. Now, without using those points, there's generally another way to name a line if it's provided, and notice there's this one lowercase m for this line. Now, if you're going to use the lowercase letter, you actually have to write the word line, and this is line M. Next example here, can you give 2 other names for plane T? Notice using the capital letter T, that one capital letter in cursive is used to identify this plane. The other way to name a plane is to give 3 points on that plane in any order. So I'm looking at points on this plane, and I see A and B and C and E, and I can do any combination of those letters. So maybe I'll call it plane ACE because I like that I can spell ace. And again, I have to write that word plane. Let's pick a different combination of 3 points on the plane. How about BCE? And you might be wondering, could I pick all 3 of these on the line? Yeah, you can, and that's totally fine as well. They're all on the plane. Next example, name 3 points that are collinear. Again, co means together, linear means line. Can you name 3 points that are together on a line? there are two lines in this picture. We have a line here and here, line M and line K. I want to name 3 points that are collinear. And if you notice, there's only 2 points on this line, only D and B. So I'm going to have to name the 3 points on this line, which is A, B, and C. And if you're just listing points, you just write them out. And for this last one, name 3 points that are coplanar. Again, what does coplanar mean? It means together on the same plane. Planar meaning plane, so give me 3 points that are together on the same plane. There are a total of 4 points on this plane, A, B, C, and E. Of course, D is not on the plane, it's outside of it. And we're not sure whether this line is on the plane or not. So I could give A, B, C, and E. You know what, they said 3. I'm just going to list all of them and write any combination of 3 would work. Okay. Some more definitions. We talked about points, lines, and planes being our basic undefined terms, and now we're going to define 2 new terms. We have line segments and rays. A line segment is a line, but it's only a segment of a line, meaning it ends and has a beginning point. So it has a beginning and end. It's a segment. It doesn't go on forever. In general, if you just say line, you're talking about something that goes on forever with 2 arrows. But a line segment has 2 endpoints. And we talk about all the points in between being part of that line segment. If you notice, this one that I picked has a point for the beginning and the end. It's not infinite. So I'll call this L and this S. These points L and S for line segment LS. And all of these points in between that made up this line segment. Now to name a line segment, you still use 2 points or 2 letters, except this time when I do line segment, I'm not going to put arrows on the end. You don't have to really do the dots. I could also do line segment SL. Again, line segment over the top, no arrows because it's a segment. For line segments, you do not do the lowercase 1 letter like we did for lines either. And the most interesting thing on this page here, array. Now, array begins at an endpoint and continues in one direction. So it has one endpoint and one direction where it continues. I should be indicating that there's a point or an endpoint here. We'll do R. And then we do have to have another point when we want to name it to describe what direction it continues in. Now to name array, it's actually really specific and it's really picky about how you name it. You have to give the endpoint letter first. So this is ray, R-Y, and when you do the ray over the top, you have to be pointing to the right for any time that you write the actual name of this. So this is ray, R-Y. You would not say ray, Y-R. Okay, you have to put the letter of the endpoint first. I guess the trickiest way for this to be would be if it was drawn sort of backwards in a sense. And let's put 2 points on here. For this ray, again, when you're going to name it, you always have to have the arrow to the right. So you should always be listing the endpoint letter first. Now the endpoint is here at P. So this is ray P, and then you name in the direction we're going forever, which here is the letter Q. So just be careful of how you name rays. Make sure you actually begin at the endpoint when you write it. What are opposite rays? This question applies to this picture here. Now, if you just think about opposite, it means something about totally different, right? Well, opposite rays have to be on a line, and they have to go in opposite directions. They have to have the same endpoint, but going in different directions because they are opposite. Now, if you notice here, the endpoint that I would have to use in common would be the point kind of in the middle here, which is G. So I could talk about, from G, I could talk about one ray going to the left, and from endpoint G, I could talk about the other ray going to the right. Remember that that endpoint letter has to always be named first. So when I'm talking about ray GH, it makes sense to go in order this way. G is the endpoint. I'm going to go forever in the direction of H, and that really only includes this side of the line. But then when I want to talk about the opposite ray going this way, again, name your endpoint first, G, and then goes forever in the direction of F. ray GF. Again, when you write it or name it, you always have to go to the right with that arrow. So these would be opposite rays. Same endpoint, going in opposite directions on a line. Another example here, looking at this picture, give another name for PR. What are we talking about here? This is a line segment, because you notice there are no arrows, so it's a line segment PR. That would only be talking about then the segment between P and R. Since we're saying line segment, there's no arrows, I'm not interested in this part that goes out forever. I'm not interested in this part that goes out forever, only the segment between P and R. And again, to give another name for it, I would just change those letters. Line segment RP, again, no arrows, we're talking about the segment. And then I want to name all the rays with endpoint Q. Here's Q. All the rays, remember a ray goes out in one direction forever. Well, from Q I could go out through T. From Q I could do a ray out through P, or from Q through S, and from Q going to R forever. So there's actually 4 different rays I could name here. QT, ray QP. Again, I'm always going to start with letter Q, that's the endpoint. I'm going to give the letter of the direction I'm going forever second. The arrow always goes to the right when I name these rays. And the last question here, which of these are opposite rays? Remember that opposite rays have to have the same endpoint, but then they go in totally different directions on a line. So if I would start with that ray QT, that was the first one I named before, what's the opposite ray from that? We'll go the other direction on the line, from Q out through S. And those would be opposite rays. And then ray QP, which is the next one I named. Where's my opposite ray? I keep going on the line, but in the other direction. So ray QR, these would be another set of opposite rays. Again, going different directions on a line, same endpoint. Alright, last set of definitions and examples here. Talking about that word intersection. 2 or more geometric figures intersect. We need a definition for this word intersect. If they have 1 or more points in common. For things to intersect, it means they have 1 or more points in common. Some more, I guess, familiar words for intersect. You should be thinking, what else do we say when things intersect? It's where they cross or where they meet. Okay. Intersect is when things cross or meet. It's when they have something in common. And another term here, things intersect if they cross or meet. The intersection of those figures is the set of points that they have in common. Set of points they have in common. This is the intersection, is what they have in common. It's where they cross or meet. Well, I guess I didn't need to write those. I put them here. So we're looking for things that cross. We're looking for how they cross, which is the actual intersection. Now the cool thing is that an intersection could be a point. It could be a line. It could be a plane. The intersection is what they have in common. And I'm actually going to have you do these examples, and we'll talk about them tomorrow in class. But I want you to practice working with intersections. I want you to sketch, or I guess if you don't want to sketch, if you're not good at drawing them, you could describe in words. But sketch 2 lines that do intersect, 2 lines that cross, or 2 lines that meet. Also, can you sketch 2 lines that do not intersect, that don't cross or don't meet? So that's the first example, 2 types of intersections or not intersections with lines. In example 2, I want you to sketch a plane, which is, again, a flat surface that goes on forever, and a line. So think about a plane, a flat surface like the floor, and a line. There are actually 3 possibilities for how a plane and a line can intersect. And I want you to either draw or describe an example of those 3. So think about a line, think about like your pencil or a table leg, and think about how those things could cross or intersect with like the floor or the ceiling. Draw or describe those. Example 3, I want you to sketch 2 planes, again 2 flat surfaces that intersect. And what is their intersection? This one's a little bit different than what we've seen for the previous examples. 2 planes that cross, 2 planes that intersect, and what does their intersection look like? If you need help with this one, look around the room and see if you can identify 2 planes that intersect. And finally, example 4, sketch two planes, flat surfaces, that do not intersect. They don't cross or meet at all. And again, we're going to go over these tomorrow in class. So today, working with our 3 undefined terms in geometry that help us define everything else we're going to talk about all year, points, lines, and planes, and some other basic definitions.